Typing is a challenge for beginners and advanced users alike. Finding a first set of good models quickly is what advanced users want to do, and getting to a suitable model which fits your task is often the problem for beginners. Both of these challenges can be solved with the Auto Model feature, so that the beginner can create a model with confidence, and for the advanced user, it saves a lot of time getting started. So let's see how it works. The first step is to select some data. You can either choose some data you have in your repository, which is your local archive, or you can import it from a file or database. We will, for most of this demo, use one of the samples which gets shipped with RapidMiner Studio. A good choice is the Titanic dataset, which has 1,300 examples and 12 columns of different data types, with a good mix of numeric and polynomial attributes. Now for the dataset, as you can guess from the name, we have a collection of the known information about the passengers which embarked on the famous maiden voyage of the RMS Titanic from England to New York. The example set contains, besides personal data like age, gender, and number of family members on board, also information about the class in which they traveled, ticket price, or where they boarded the ship. Now, of course, with this data, the most interesting challenge is to try and model the potential survival of each passenger, and therefore the task at hand is a classification problem. Our label or target variable is obviously the attribute named survived. In this next step, we're asked to identify which value of the label is, for us, the important one. In our case, we have only 2 classes, and we're interested in yes. You can also rename the classes or reduce the number of values by mapping several classes to the same value. Now, this next page is particularly interesting and important. Every attribute of our example set is shown here with a tick box, a traffic light, and a quality chart. The status colors mean the following. Red should most likely be excluded from the model creation process. Orange, make sure to double-check if you really want to select this attribute as input. Green, this seems to be an important input for model generation. Selecting the right inputs for modeling is important to make sure you include every relevant aspect, but it's also important to exclude unimportant features, which only increase the runtime, so make sure to review this carefully. Here on the right, we have our information panel, which will help to understand the quality chart better. The quality chart gives you an indication on correlation between an attribute and the label, the ID-ness, the stability, and the fraction of missing values in a column. As mentioned here, in general, you should prefer columns with low values for missing, stability, and ID-ness. A lot of missing entries will not help to find patterns for explanation, so that's a no-brainer. Now you can see why cabin is flagged to be excluded as clutter. Stability is high if the values in an attribute showing little to no variation. Again, not helpful for pattern identification in that case. ID-ness tells you how much a column is like a unique identifier, which means each value appears only once in an attribute, and therefore, again, is not useful in finding patterns. A random ID like the ticket number or something as specific as the name of a passenger clearly is of that type. Lifeboat is flagged orange, which tells us that this is something where RapidMiner is unclear if it's a good idea to select this attribute. Missing is high because most people didn't make it to 1, and therefore these values are missing. At the same time, the correlation between this attribute and the target, which we want to predict, is very high, so we might have a great proxy here. Our challenge is to predict if someone is going to survive, assuming the incident has not happened yet, but the information on lifeboats is a result of the disaster. So due to the causality of the correlation, we have to exclude the attribute. Now on this page, we get a pre-selected subset of suitable models with respect to our task and to the size of our example set. For some of them, regularization or optimization is very useful to get a better performance, so we can choose to include this automatically here. If you're concerned about the runtime, you can decide to untick it, but it will be best to leave it on. Besides creating the models and some helpful analytics on each, we'll also create a general correlation matrix and an overview on the importance of the columns. You can turn this off here in case you're not interested in that, but we won't, so we can show you what it looks like. All right, now let's hit the Run button. This will take a bit of time because we're calculating all the models, including validation and optimization. By selecting the overview, we can, however, look at what has happened so far already now. Okay, the last entry here is empty, so it is the gradient boosted tree which is taking some more time. That's not surprising because it is an ensemble model and therefore is calculating many different trees. In the table below the graphs, we get the runtime of each model and a selection of performance matrices. If you're not sure which one to look at, then we recommend considering accuracy, but also the robust AUC, which stands for area under the curve. As I click on the rock comparison, you can nicely see the curves from which the AUC is calculated. To understand more about the ROC curves and the different quality measures, please refer to the tutorials on validation and model identification, respectively. Now, as we switch back to the overview, we see that so far, random forest is the model with the highest AUC, but also required a multiple of the other model's runtime. For the gain of only about 0.5% higher AUC, we had to pay a high price with the amount of runtime. The same applies to our gradient-boosted tree, which has just been completed. So the auto model feature provides a great help here for you to find the most economic approach between calculation time and performance. Before we look into the details which are provided with each model, let's first look into the general section up here. The data section is obvious, so I'll move on directly to weights. This section helps you to quickly see which of the attributes were actually the most relevant for the model's predictions. In the case of our Titanic example, clearly the gender is the most dominant one, but it is immediately followed by monetary attributes. You can see something similar in the correlations, namely that gender and survival are comparably higher correlated as well as passenger class and fare with each other and with survival. Okay, now here at the bottom we can see some further helpful details about each of the models that have been chosen. For the decision tree, you get a nice chart and the full confusion matrix with all performance details. In the optimal parameters, you can see which parameters, if any, have been optimized and what the best values are. The last two entries shown here are lift chart and simulator. The simulator is very helpful to run through some what-if scenarios, and it includes the option to ask RapidMiner to perform an optimization. For example, you can ask for the following optimization. How can I maximize my chance to survive given that I'm a 40-year-old man who embarks on the voyage in Cherbourg? Now you can see that even with optimized conditions, the chance for survival in this case can only be increased to slightly above random chance. And since age and gender were predetermined, you'd better make sure to travel in first class, as the biggest supporter of a positive survival outcome. The lift chart is often used, for example, during marketing campaigns and helps to assess the impact of using a model to identify campaign targets as compared to just sending out messages randomly. Last thing to demonstrate here is what happens if you have some examples in your data set that you want to predict. For that, we'll select the customer data, which we've been using also in the other tutorials. Check out the video on data loading to find out how it's imported. As you can see, the churn label contains some missing values. We will go through the next steps here rapidly since we've just explained them, and to speed things up even more, we'll avoid the calculation-intensive gradient-boosted tree model. While the remaining models are calculated, we can already see the predictions for our unlabeled data as made by the naive Bayes model. The green and red colors are helping you to understand why an example was classified positive or negative. So this example here was classified as loyal despite the fact that the customer is female, which otherwise would have been more an argument for churn. But if you look at the confidence, then this is not a very strong case. This example here, in contrast, was classified as churn with all values across the 4 attributes supporting this decision, with a very high confidence. If you're an experienced user, then one thing you may have been asking yourself during this demo more than once is the question, what if I want to do something different than the options provided? For example, what if I want to optimize other parameters? In that case, you can simply click down here on Open Process, and you're free to change or add anything you like, with the big advantage that you won't need to start from scratch. So, Auto Model is not a black box which you can't control, but rather a customizable and transparent feature to support your productivity. With this, we want to end this tutorial, and we thank you very much for watching.